Meaning of this ionic equilibrium, most probably the second last lecture for this ionic equilibrium. Hope everyone is getting my voice well, and even picture clarity. Okay, so we are here with ionic equilibrium, and as I stated, it may be a second last lecture for this ionic equilibrium because we are almost at the concluding part of the chapter. Yesterday, we have discussed that is Buffer solution. So we have seen Buffer solution is a solution which has a definite pH, and its pH do not changes even though a small quantity of strong acid or strong base is added, and that is what is a buffer solution. We know it very well. There are two types of buffer solution: acidic buffer and basic buffer. Acidic buffer is a mixture of weak acid and its salt with strong base, whereas basic buffer is a mixture of weak base and its salt with a strong acid. We have also seen the mechanism why the pH of buffer solution do not changes. Why the pH of buffer solution do not changes, that is also what we have seen with the mechanism yesterday. Then the last part what we have seen yesterday is nothing but you can say properties of buffer solution. What are the properties of buffer solution? That is what we have seen, and the topic left in that is nothing but you can say applications of buffer solution. So today we'll discuss the applications of buffer solution, and then furthermore we'll go ahead with the topic what we have discussed today is nothing but the solubility equilibria or solubility product. So let's move applications of buffer solution. Okay, so let's move to this applications of buffer solution. Applications of buffer solution. As I stated, buffer solution is a solution which has a definite pH, and its pH do not changes even though small quantity of strong acid or strong base is added, and that solution is called as a buffer solution. This buffer solution has wide applications in many fields, many fields. So number one is in biological process. Biological process or biological way. Next is you can say agriculture. Next is analytical chemistry, analytical chem. Next is nothing but you can say industry, and fifth one is nothing but medicines. So these are the different industries. These are the different fields where this buffer solution is of immense importance, is of very importance. Now, what is this biological process? Already I have given this example, the example of human blood. The pH of human blood is almost 7.36 to 7.42 in between. This is the pH of human blood. जैसे मैंने कल आपको बताया कि pH of human blood is 7.4. So actually the human blood pH lies in between this 7.36 to 7.42. This is the pH of human blood, and the change in pH of 0.2, okay, the change in pH of 0.2 may cause or may lead to the death of human being. So how much important this pH, we can understand the value of this one. The change of 0.2, 0.2 change, मतलब अगर ये pH 0.6 होता है या फिर यहाँ पे देखेंगे तो 7.1 होता है, so it may lead to the death of human being. This is the importance of pH because many reactions are going on in our body, in human body, and all these reactions took place very well at a proper pH, and that's why the pH of human blood has to be maintained in between 7.36 to 7.42 in between, and the 0.2 change in pH may lead to the death. This is the importance of pH in biological process. Whatever the injections, intravenous injections are given, intravenous and salines are given, where the pH need to be maintained here in between this one. Then only then that medicine can be given intravenous, or you can say that is saline, all can be given to the person or individual. So that is the importance of pH in biological process, number one. Number two, agriculture. We know very well particular production of crop or particular crop need a particular pH. हम अच्छी तरह जानते हैं कि अलग-अलग टाइप के सॉइल में अलग-अलग क्रॉप्स आते हैं और हर क्रॉप की अपनी रिक्वायरमेंट होती है. तो जिस तरीके से रिक्वायरमेंट न्यूट्रिएंट्स की होती है उसी तरीके से रिक्वायरमेंट पीएच की भी होती है. So that's why the pH of soil also matters a lot for a different crop. different pH is required. And that's why we can say like that. Different soil has a different pH, and that's why that may be suitable for that particular type of crop production and all. Generally, there are many substances as like carbonates, bicarbonate, phosphates, which are present into the soil, and they maintain the pH of soil. So whatever the fertilizers we put, that fertilizers should have also the pH in between this one. So that matters a lot. So in that sense, in agriculture industry, the pH of soil has to be checked. In modern agriculture, the pH is always regularly checked and it is maintained by adding some fertilizers and all. Naturally, जैसा मैंने बताया आपको कि carbonates, bicarbonates, phosphates, these are the substances which are present. These are the salts which are present in the soil, which maintain the pH of soil in between, particular for that crop production. जरूर मतलब जैसे ह्यूमन ब्लड के वैसे हर क्रॉप के लिए थोड़ा अलग अलग पीएच रेंज की जरूरत होती है, दैट इज मेंटेन्ड बाय दिस सब्सटेंसेस. सो इन एग्रीकल्चर इंडस्ट्री pH is also very important. Next, we come to this analytical chemistry. When we talk about analytical chemistry, we are in 12th standard, so we have done experiment in 11th standard. दुर्भाग्य से 12th standard में हम लोगों को एक्सपेरिमेंट करने का मौका नहीं मिला है. लेकिन अगर हम करते हैं 12th standard में जितने सारे एक्सपेरिमेंट हमारे लैबोरेटरी में होते हैं, वो सारे एक्सपेरिमेंट के अंदर हम लोगों को एनालिटिकल केमिस्ट्री, जहाँ पे हम लोग ग्रुप एनालिसिस करते हैं, हमें सब्सटेंस दिया जाता है और उस सब्सटेंस का पाउडर का हमें ग्रुप फाइंड आउट करना है कि व्हिच फंक्शनल ग्रुप इज प्रेजेंट इन दिस गिवन कंपाउंड, एंड फॉर दैट वी हैव टू फॉलो द एनालिटिकल मेथड. That is, group first is present or absent, group second is present or absent. That we may follow the particular method to find out the group of that substances. So here, if we look up towards the group third A, अभी ये थोड़ा सा आपने एक्सपेरिमेंट ज्यादा किया नहीं है, इस लैब में नहीं थे, इसलिए थोड़ा सा रिकॉल करना मुश्किल होगा. अगर आप लैब में होते थे, 11th स्टैंडर्ड में था, आपको थोड़ा बहुत रिकॉल हो रहा है तो अलग बात है. और अभी अगर किसी के एक्सपेरिमेंट शुरू हो चुके कॉलेज में या हो जाएंगे बनने से, तो आपको थोड़ा उसका आइडिया आ जाएगा, बिकॉज इट्स वेरी सिंपल एंड क्लियर. For the group detection of third A elements, we need to maintain the pH between 8 to 10. See, pH in analytical chemistry for the group detection third A, it is maintained between 8 to 10 pH. So here, third A group elements where we need a pH 8 to 10 in between. 8 to 10 in between pH is needed, and this is maintained with ammonium hydroxide and ammonium chloride. So ammonium hydroxide and ammonium chloride, they are the substances which maintain the pH in between 8 to 10 in analytical chemistry in order to find out third A group elements. So that is in analytical chemistry. So that is कई बार आपको बताया जाता है ग्रुप डिटेक्शन के अंदर कि add ammonium hydroxide till the basic solution, till the alkaline solution, add dilute HCl till the solution become acidic, मतलब pH should be less than 7. इस तरीके से होता है, मतलब till alkaline, till basic, till acidic, इस तरीके के वर्ड्स वहां पे यूज किए जाते हैं. लेकिन अगर हम लोग बारीकी से देखते हैं, so this is the pH which is needed to have the identification of elements of that particular group. Third A group के लिए pH is maintained between 8 to 10. So that is what we can see here in analytical chemistry. That is also one of the importance. Industry की बात करते हैं. There are many paint and dyes industry. There are different types of paint what we have, and there is a big industry which is related with the dyes. Dyes again, it's a part of painting, like color like, because we have wide applications of these dyes and paints. In that industry, the pH has to be properly maintained. That pH will give a particular product very well, or good quality of the product. And that's why in industry we need to maintain the pH of this over here. Next is nothing but the medicines. Many medicines need to be preserved very well, and especially we know very well penicillin is a very important antibiotic that has to be stabilized by using a sodium citrate salt, and sodium citrate salt acts as a stabilizer which maintain the proper pH, and that's why the penicillin can be stored for a long time with this one. So activity of penicillin also increases with this one. So in medicine industry, pH also matters over there. So I have given the example of penicillin. Even milk of magnesia, where magnesium citrate salt is used to maintain the pH of the solution. Food industry के अंदर sodium benzoate is used, which maintain the pH again. So there are many examples here, medicine too again, and back industry. So all these are the applications of buffer solutions in our daily routine life. Be clear here? Applications of buffer solution, as stated, buffer solution is a solution which has a definite pH, and its pH do not changes even though small quantity of strong acid and strong base is added. And when we talk about this pH, we have pH importance in biological process, pH importance in agriculture industry, pH importance in agriculture industry, analytical chemistry, pH importance in other industries, production industry, and here pH importance in medicines. That is what we have discussed. It's very simple topic. ये learning का part है, books से भी आप पढ़ सकते हो और समझ भी लेंगे तो ज़्यादा better है. Clear? So that is what we have done here. Perfect solution. Now let's move to the second last topic of this chapter. There are only two topics remaining. Number one is solubility equilibria and you can say common ion effect. So we are here with solubility equilibria. Solubility equilibria. So let's move to the solubility equilibria over here. What is this solubility equilibria? अभी देखिए already इस chapter के starting में हम लोग deal कर रहे हैं substances के साथ और we have seen substances can be classified as electrolytes and non-electrolytes. Electrolytes are the substances which, when put into the water, produces cations and anions, and these are called as electrolytes. And the substances which do not produce cations and anions are called as non-electrolytes. Electrolytes के अंदर जो substances आते हैं वो acid, base and salts की बात करते हैं. और electrolytes को अगर हम दो कैटेगरी में क्लासिफाई कर सकते हैं, that is strong electrolytes and weak electrolytes. हम अच्छी तरह जानते हैं strong electrolyte dissociate completely, whereas weak electrolyte dissociate partially. So we have seen that. ये हमने डिस्कस किया हुआ है. अभी बात हम कर रहे हैं कि solubility equilibria ये किसके लिए लागू है? तो solubility equilibria ये salts के लिए लागू है, but these are not the salt which dissociate completely. These are the salt which dissolves in very small amount, and this is called as sparingly soluble salts. Be clear here. Word is very important. Sparingly soluble salt. Sparingly soluble salt. So, what is meant by the sparingly soluble salt? The salts which dissolves in very small amounts are called as sparingly soluble salt. There are many examples of this sparingly soluble salt. We can have here, say, we can have AgCl. We can have here PbS2. Then we can have PbSO4. Okay. Then BaSO4. Okay, these are the salts. Many salts are there, and these are the salts which we can see here. These are sparingly soluble salt. Even aluminum fluoride, like these are the substances which are, you can say, sparingly soluble salt. These are the salts which, when put into the water, they dissolve and dissociate. But very small amount that of these salts dissociate. Normally, rest of the salt, baki salt, are considered to be 100% ionized. They are considered to be strong electrolytes. There is a list of some salts which is called as a sparingly soluble salt, because these are the salts which dissolves or dissociates in very small amount, and that's why they are called as sparingly soluble salt. So when we have to discuss the solubility equilibria, so this is related with sparingly soluble salt. Let's come with some one example. Say suppose we are here AgCl. AgCl is a sparingly soluble salt. This salt dissociates into the water. When put into the water, it produces Ag plus Cl minus. Again here aqueous, here aqueous aa jata hai. So that's what we can say. This is the dissociation salt, and it has to be used by double-headed arrow. The reason behind that, this is sparingly soluble salt. Generally, बाकी salts के लिए हम लोग single-headed arrow use करते हैं. NaCl, KCl, NH4Cl. But ये sparingly soluble salt का जो category है, उस category के हम लोग double-headed arrow use करते हैं, because they dissolve or dissociate in very small amount, and that's why they are called sparingly soluble salt. Now, इस equation को अगर हम law of mass action apply करते हैं, तो we can say applying law of mass action. जो हमने एसिड को भी किया था, जो हमने बेस को भी किया था, जो हमने बाकी सॉल्ट को भी किया था, उसी तरीके से इसे हम लोग इस इक्विलिब्रिया को, इस रिएक्शन को, जो रिवर्सिबल रिएक्शन है, और रिवर्सिबल रिएक्शन होने के कारण देयर इज अ फॉरवर्ड रिएक्शन, देयर इज अ रिवर्स रिएक्शन, दैट व्हाई देयर लाइज अ इक्विलिब्रियम. इक्विलिब्रियम तभी आएगा ना व्हेन देयर इज अ फॉरवर्ड रिएक्शन, रिवर्स रिएक्शन, और उसका इक्विलिब्रियम होगा अनडिसोसिएटेड AgCl molecules and Ag plus and Cl minus molecule, इनका इक्विलिब्रियम आएगा. So applying law of mass action, we got this one. तो अभी देखिए, जब हम इसे law of mass action को अप्लाई करते हैं, तो we can have here K is equal to product of concentration, that is the concentration of Ag plus into concentration of Cl minus upon concentration of AgCl. ये इक्वेशन हम लोगों को मिल जाता है. Okay, we got this equation. So it's very simple. जो हम लोगों को जिस तरीके से K मिला था, जिस तरीके से हमें Kb मिला था, जिस तरीके से हम लोगों को Kw मिला था, उसी तरीके से यहाँ पे हम लोग का भी K मिल जाता है. But यहाँ पे इस वर्ड को एक बार याद रखना कि दिस इज स्पेरिंगली सोल्यूबल सॉल्ट, मतलब जिस तरीके से हम लोग कहते हैं कि वीक इलेक्ट्रोलाइट्स आर पार्शियली डिसोसिएट, दे डिसोसिएट पार्शियली, बहुत कम क्वांटिटी डिसोसिएट, उसी तरीके से ये भी सॉल्ट स्पेरिंगली सोल्यूबल सॉल्ट है, इनकी भी बहुत कम मात्रा, कम क्वांटिटी डिसोसिएट होती है, डिसॉल्व होती है। तो इस केस में हम लोग कह सकते हैं कि ये जो AgCl है इसका बहुत ही छोटा अमाउंट यहाँ पे डिसोसिएट होगा, बहुत बड़ा अमाउंट यहाँ पे रहेगा जो अनडिसोसिएटेड फॉर्मेट में रहेगा। So मतलब this concentration of AgCl is going to maintain constant. It is not going to change. हमने जो इनिशियली लिया है उसमें और इसमें ज्यादा फर्क नहीं रहेगा क्योंकि बहुत कम क्वांटिटी उसका डिसोसिएट होने वाला है। मानो हमारे पास अगर 100 मोल्स है तो उसमें से एक दूसरा मोल डिसोसिएट होगा, बाकी वैसे के वैसे रहेंगे। So in that sense this concentration will remain almost constant. तो this concentration remains constant. उसे हम लोग ऐसे करते हैं K is equal to concentration of Ag plus into concentration of Cl minus. We'll make it K dash. K dash is nothing but the concentration of AgCl, which is almost equal to initial constant. The reason behind that it is sparingly soluble salt. ये sparingly soluble salt होने के कारण इसका जो initial concentration है वो almost वैसा का वैसा रहेगा. That's why we have taken K dash. मैं K dash की तरफ carry करता हूँ तो it will be K into K dash and is equal to concentration of Ag plus into concentration of Cl minus. ये हम लोगों को मिलेगा. अब ये दोनों को K into K dash के लिए एक नया K लेके आते हैं, that is called KSP, and this is nothing but concentration of Ag plus into concentration of Cl minus. So this is the final equation what we get here, जिसके अंदर this KSP is called as solubility product, या फिर K into K dash is called as solubility product. इसी को हम लोग कह सकते हैं solubility product. So we can say this is called as solubility product. Solubility products हम लोग कहते हैं उसे. So that is what we can see. So this KSP is called as solubility product. अभी तक हमने K देखा था, हमने KB देखा हुआ है, KW देखा हुआ है, उसी तरीके से यहाँ पे हम लोगों को KSP मिलता है. ओके, बट हमने K एसिड के लिए देखा था और एसिड का जनरल रिप्रेजेंटेशन था HA. K भी हमने बेस के लिए देखा था जिसका जनरल रिप्रेजेंटेशन था यू कैन से BOH. सॉल्ट के लिए देखा था हमने BA, राइट? ये भी एक सॉल्ट है, इसके लिए भी एक जनरल रिप्रेजेंटेशन होगा, दैट इज नथिंग बट यू कैन से BA. सो यहाँ पर भी हम लोग देखते हैं दैट इज जनरल रिप्रेजेंटेशन के साथ. सो वी कैन हैव BA. सो दिस इज BXAY. सो ये सॉल्ट होता है. ये सॉल्ट क्यों? देखिए ना, अभी यहाँ पे देखते हैं हम लोग कि इसके अंदर एक सॉल्ट लेते हैं PbCl, ओके, या फिर AlOH थ्राइस. अब देखिए यहाँ पे Pb का एक ही एटम है और क्लोरीन के दो एटम है. सो इसके अंदर अभी तक हम लोग सिर्फ Ba लिख रहे थे, अभी यहाँ पे हम लोग BXAY लिखते हैं. तो ये B indicates a cations, A indicates anion, X represents the number of atoms of B and Y represents number of atoms of A. So थोड़ा बड़ा लिखता हूँ मैं, BXAY. This is the salt. और ये सॉल्ट जब डिसोसिएट होगा, ये सॉल्ट डिसोसिएट होगा तो क्या मिलेगा? B मिलेगा cations प्लस A मिलेगा anions. A मिलेगा anions, ये सॉल्ट होने के कारण. लेकिन जैसा भी यहाँ पे देखिए सिल्वर के केस में देखते हैं, सिल्वर के ऊपर चार्ज 1 है, क्लोरीन के ऊपर चार्ज -1 है. बट हम ये सल्फर की बात करते हैं, सल्फर के ऊपर -2 चार्ज होता है. ये लेड के ऊपर +2 चार्ज होता है, लेड के ऊपर +2 चार्ज होता है. तो चार्ज में भी वेरी और मे बी डिफरेंट. तो होता क्या है कि इसका जो चार्ज होता है, कैटायन का चार्ज इसके जैसा होता है और कैटायन का चार्ज एनायन जैसा होता है और एनायन का चार्ज कैटायन जैसा होता है. सो आई कैन सी हियर BY प्लस या प्लस Y या AX माइनस, क्योंकि X is the number of atoms of B and Y is the number of atoms of A. So this is being a neutral molecule. ये चार्ज इस चार्ज को कैंसिल करता है. So X must be multiplied by A and Y must be multiplied by B. इस तरीके से आपको मिलता है चार्ज के लिए, हर चार्ज के लिए. तो BY प्लस और AX माइनस इस तरीके से हम लोगों को कैटायंस एंड एनायंस मिलते हैं इन केस ऑफ स्पेरिंगली सोल्यूबल सॉल्ट. इसे हम लोग ये भी होता है कि इसके जो यहाँ पे एटम X है, that's why we get here X moles. यहाँ पे हम लोग Y है, so that's why we get Y moles. So ये भी हम लोगों को इस इक्वेशन के अंदर मिल जाता है. Now इसे भी लॉ ऑफ मास एक्शन अप्लाई करते हैं हम लोग. तो अप्लाइंग लॉ ऑफ मास एक्शन, applying law of mass action, what we get here theorem here, K is equal to concentration of B Y plus raised to X, and here A X minus raised to Y upon concentration of BX A Y. ये हम लोग मिल जाता है. This concentration is almost constant. This concentration is almost constant, like K dash. So we can say K into K dash is equal to K into K dash is equal to. ये तो इस तरफ लेके गए, K dash करके इस तरफ गया है. ये चलो एक स्टेप बढ़ाता हूँ. Is equal to concentration of By plus raised to x, concentration of A x minus raised to y upon K dash. K dash की तरफ लेके आएंगे. K into K dash is equal to concentration of By plus raised to x and A x minus raised to y. So here, this is nothing but the KSP, which is equal to concentration of By plus raised to x, concentration of x minus raised to y. So this is the solubility product, what we get here. This is the solubility product. So KSP is known as solubility product. KSP is known as solubility product. So the matter is nothing but the solubility product. So we have to define the solubility product. क्या है ये solubility product? So we can see here this when we talk about the solubility product. Solubility product is the product of cations and anions. Product of cations and anions raised to suitable power. Raised to suitable power. Raised to suitable power. This power is nothing but the coefficient. X is the coefficient of here. Y is coefficient over here. So the coefficients are raised to suitable power. Coefficients are raised to suitable power. This is nothing but you can see here solubility product. So solubility product is the product of cations and anions of the salt raised to suitable power with the coefficient ions, with the coefficients. So that is what we get here, solubility product. तो ये हम लोग solubility product मिल जाता है, and that is what we can say solubility product. तो solubility product का definition भी आ जाता है and equation भी आ जाता है. This is the particular example what we have seen, and here is you can say a generalized equation for this one. जिस तरीके से हमने K देखा था, जिस तरीके से हमने Kb देखा था, और जिस तरीके से हमने Kw देखा था, उसी तरीके से यहाँ पे Ksp देखा हुआ है. We have seen the Ksp. Clear with this? So that is what we can say. That is called as a solubility product. Now इसी solubility product को और अगर generalize करना है हम लोग को, इसी solubility product को हमें solubility के साथ connect करना है. When we talk about the solubility can be given, that is you can say moles per dm cube or grams per dm cube. That solubility can be given by these two different ways. So we have to discuss that solubility in generalized way. You have the relation between solubility and the solubility product, because we talk about this KSP, and this KSP is nothing but the solubility product. And the next topic related with this, what we have to see is nothing but the solubility product. जिस तरीके से मैंने AgCl का एग्जांपल दिया है, उस तरीके से सारे salts है. ये सारे salts है. We can have the example of this, all of these salts. We can have the PbCl2, we can have BS4, we can have aluminum hydroxide. We can have the dissociation of all these salts, which are called sparingly soluble salt. So once we design this sparingly soluble salt, we can have this one. Clear with this? So that is what we can say. We have the examples of this sparingly soluble salts. Clear with this? So let's move. The relation between solubility and solubility product. Okay, solubility is given by S and solubility product is given by KSP. So we have to actually find out the relation between KSP and S. So S is the solubility and solubility product is nothing but the KSP. KSP तो अभी हमने देखा this is the KSP. किसी भी equation के लिए दिखा जाता है. अभी यहाँ पे particular example था और यहाँ पे हमारा generalized example. तो KSP is given by this one. Now what is S? We have to discuss in solubility क्या है. So let's have the formula of the solubility. उसके अंदर आता है molar solubility. Molar solubility. Molar solubility is nothing but number of moles dissociated upon volume in dm cube. Volume in dm cube. So volume in dm cube. Yeah, so solubility, molar solubility is given by S is equal to number of moles m upon volume in dm cube. Volume in dm cube. So that is what we can say solubility. Okay, that's what we. Yeah, we solubility का दूसरा एक formula that is you can say solubility is equal to weight in gram upon volume in dm cube. So solubility is equal to weight in gram, that is W in gram divided by volume in dm cube. So this is you can say gram per liter, and this is you can say moles per liter. That is what we get here. So here we get here moles per liter, and here we get here grams per liter. So these are the two different ways by which we can calculate the solubility of the substance. Getting it? So we have the solubility given in moles per dm cube, that is moles per liter. Liter matlab dm cube matlab liter, and this is the solubility given grams per liter or grams per dm cube. This is the two different ways by which we can give the solubility. तो solubility का मतलब क्या होता है कि हमने जो salt पानी के अंदर पुट किया है वो कितना dissolve हुआ है, कितना dissociate हुआ है in a given amount of solvent. So the amount of solute dissociated in given amount of solvent is nothing but the solubility, and this solubility is given by this first formula, molar solubility, number of mole dissociated upon the volume total given, and दूसरा weight in gram dissociated upon the volume given. So दोनों तरीके से वो दिया जाता है, that is nothing but the solubility. एग्जाम में क्वेश्चन आ सकता है, solubility can be given in grams per dm cube or solubility can be given in moles per dm cube. दोनों में से किसी तरीके से solubility दिया जा सकता है, that is what we have discussed here. फिलहाल में हमारा टॉपिक है रिलेशन बिटवीन solubility and solubility product, ये हमें डिस्कस करना है. So let's go to this one. ये इसके लिए हम लोग चलते हैं. टॉपिक है, ये दो फॉर्मूला लिख लीजिए, उसी हिसाब से हम आगे चलते हैं. ओके, तो what is this equation? हमारे पास ये इक्वेशन है जो हमने ऑलरेडी यहाँ पे लिखा हुआ है. So this is, you can say, BXAY salt dissociate to produce X moles of BY plus Y moles of AX minus. ये salt मिलता है. अगर हम ऐसा मानते हैं कि consider S is the solubility. Solubility can be expressed in moles per dm cube या फिर gram per dm cube. S is the solubility of the given substance. Initially we have taken 1 mole, इसके 0 होंगे, इसके 0 होंगे. बाद में इसका जो solubility है वो S है, so that's why इसके S moles तैयार होंगे, इसके S moles तैयार होंगे. Okay, but यहाँ पे दिखता है XS moles, तो we can say XS mole, यहाँ पे होगी YS moles. S is the solubility. इसके moles तैयार हो रहे हैं. एक मोल के लिए S solubility है. For 1 mole it is S solubility. For X mole it is X into S. 1 mole के लिए S solubility है. Y moles के लिए Y into S solubility रहेगा. So this is the solubility what we get here. Now by applying law of mass action we got this equation. ये equation हम लोगों को मिल जाता है. By applying law of mass action we got this equation. So we can say KSP is equal to concentration of B Y plus raised to X, concentration of A X minus raised to Y. ये मिल जाता है. Okay. So concentration क्या है? तो XS. B plus का concentration कितना है? XS. A minus का concentration कितना है? YS. तो we can say KSP is equal to, इसके बदले आएगा XS raised to X, and here AX is nothing but the YS raised to Y. So we got this one. ये इक्वेशन हम लोगों को मिल जाता है. देखिए हमने कुछ नहीं किया, जैसे हमने कंसीडरेशन किया कि हमने 1 मोल ऑफ सॉल्ट दिया था, वो हमने डिसॉल्व कर दिया. इनिशियली इसका कॉन्सेंट्रेशन 0 है. एट इक्विलिब्रियम इज अगेन S इज द सॉल्युबिलिटी, तो इसका जो कॉन्सेंट्रेशन बचेगा वो माइनस S 1 माइनस S है. तो इसका बचता है XS एंड YS, ये हम लोगों को मिल जाता है. So this is the concentration which is produced for this particular B and particular Y A moles. Now, जैसे कि हमने देखा है कि concentration of this nothing but the XS and for this nothing but the YS, we got this one, हमने यहाँ पे उसको रख दिया. अभी इसे सिंप्लीफाई करते हैं, तो KSP is equal to, यहाँ पे होगा X raised to X dot S raised to X, यहाँ पे आएगा Y raised to Y dot S raised to Y. So KSP is equal to, ये दोनों laws of indices के हिसाब से उनका base same है. So what will happen is will be X raised to X dot Y raised to Y, or here S raised to X plus Y. This is the equation basically what we get here from solubility product. This is the equation what we get here from solubility product. KSP. This is KSP. So KSP is equal to X raised to X, Y raised to Y, S raised to X plus Y, ये हम लोगों को मिल जाता है. ये now यही इक्वेशन को हमने, ये इक्वेशन है solubility product का, और this equation gives the relation between solubility product and solubility. Big क्लियर है, दोनों इक्वेशन में फर्क है. This equation gives the solubility product and this equation gives the relation between solubility product and solubility. Solubility product and solubility बीच में क्या रिलेशन है ये यहाँ पे आपको देता है. That is what we get here this equation. क्लियर? अभी देखिए अलग-अलग सॉल्ट्स है और अलग-अलग सॉल्ट के लिए we have to find out them. इन्हें फाइंड आउट करना है. अभी देखते हैं कुछ सॉल्ट हम लोग अप्लाई करके देखते हैं क्या इक्वेशन हम लोग को मिल जाता है फॉर डिफरेंट. यहाँ पे सिर्फ एक ही जरूरी कंडीशन है, salt has to be sparingly soluble salt. Sparingly soluble salt होगा तभी जाके इक्वेशन लॉग होगा, अदरवाइज हाइड्रोलिसिस होगा. जो हमने नॉर्मल सॉल्ट के लिए डिस्कस किया था वो हाइड्रोलिसिस होगा. अब देखिए AgCl का सॉल्ट देखते हैं। AgCl पहला एग्जांपल, फर्स्ट एग्जांपल, AgCl dissociate to produce Ag plus plus Cl minus। अभी देखिए ना, इस इक्वेशन में Ag is representing the B and Cl representing the A। Ag के इस तरफ राइट साइड कुछ नहीं मतलब 1 है, Cl के इस तरफ कुछ नहीं मतलब 1 है, इसके आगे यहाँ पे देखिए x 1 है और इसके आगे y क्या है 1 है। So here you can see in this equation example x is equal to 1 और y is also equal to 1। तो ये जो x मोल्स की बात कर रहे हैं हम लोग, x मोल्स, ये इसके अंदर 1 है और y मोल्स जो यहाँ पे आते हैं y के लिए, ये माइनस के लिए, वो क्या पे आते हैं 1 आते हैं। सो ये इस इक्वेशन लिख देते हैं। तो इस AgCl के लिए Ksp का वैल्यू क्या रहेगा? तो Ksp is equal to x raised to x, x से 1 raised to 1, y की वैल्यू क्या है? y is this 1 raised to 1 into s raised to 1 plus 1। So Ksp is equal to 1 raised to 1 is 1 1 1 and this is s raised to 2, तो s square। इस तरीके से इक्वेशन हम लोगों को मिल जाता है, समझ रहे हैं आप लोग? तो दिस इज द s square इक्वेशन व्हाट वी गेट हियर। सॉल्युबिलिटी प्रोडक्ट ऑफ AgCl लाइक सॉल्ट, जिसके अंदर एक ही कैटायन तैयार होता है और एक ही एनायन तैयार होता है, इस सॉल्ट के लिए इक्वेशन इस तरीके से बनता है, समझ रहे हैं आप लोग? लेट्स हैव अनदर एग्जांपल। सेकंड एग्जांपल वी कैन हैव PbCl टू डिसोसिएट, यहां पे डबल लिटेड है, PbCl टू डिसोसिएट टू प्रोड्यूस Pb प्लस twice Cl minus। अभी इसके अंदर देखिए x का वैल्यू कितना है, इसके आगे 1 है और y का वैल्यू कितना है 2 है, y का वैल्यू 2 है। सो इसका Ksp क्या रहेगा फिर? Ksp is equal to 1 raised to 1 डॉट y का वैल्यू क्या है 2 raised to 2 into s raised to 1 plus 2। सो Ksp is equal to 1 raised to 1 is 2 raised to 2 is 4 और यहाँ पे s raised to 3। This is the equation what we got for this equation। तो समझ रहे हैं आप लोग? तो हमारा एग्जांपल बदल जाता है, जिस एग्जांपल के अंदर x का वैल्यू 1 ही है बट y का वैल्यू आपको 2 दिखाई देता है, जो यहाँ पे x है यहाँ पे y है, जो इस जनरल इक्वेशन के थ्रू हमने डिजाइन किया। सो दिस इज वेरी जनरलाइज्ड एग्जांपल एंड दिस इज वेरी पर्टिकुलर एग्जांपल। तो solubility product depends upon different salts। So if x value is 1, y value is 1, then Ksp is a square, relation between Ksp and s is a square। For the salt having x value 1, y value 2, Ksp is equal to cancel 4 raised to cube। यहाँ पे उल्टा भी हो सकता है, y का वैल्यू 1 होगा, x का वैल्यू अगर 2 होगा तो हमें सेम इक्वेशन मिलेगा। तो ये आप समझते हो, ठीक है ना? अभी हम लोग तीसरा एग्जांपल लेते हैं, नेक्स्ट एग्जांपल लेते हैं। Solubility product can be calculated for different equations। So we can have example AlOH thrice, this is the salt, okay। या फिर AlCl3 है, AlCl3 सॉल्ट है, ये देखते हैं। तो इसका क्या होगा कि एल्यूमिनियम 3 प्लस थ्राइस OH माइनस। इस इक्वेशन के अंदर x इज इक्वल टू 1, मतलब ये x इज इक्वल टू 1 और y इज इक्वल टू 3, ऐसा मिल जाता है। सो व्हाट हैपेंड देन क्या मिलेगा फिर हम लोगों को इसके अंदर? सो व्हाट वी गेट हियर Ksp इज इक्वल टू 1 raised to 1 dot 3 raised to 3 dot s raised to 1 plus 3। So Ksp is equal to 27 into s raised to 4, क्योंकि यहाँ पे 3 का क्यूब है, तो 3 का क्यूब कितना आएगा? 3 into 3 into 3, 9 3s are 27 into s4। So that is what we have। So the value of solubility product is different for different salts, sparingly soluble salt। This is very important thing what we discussed under this solubility product। So relation between a solubility product and solubility is different for the different salts, depending upon the salt what the salt we do have here। So accordingly we can get the things clear with this। So that is what we have seen the solubility product। So today the solubility product is done and tomorrow we'll be having the last topic, that is called as a common ion effect for this chapter। Till then, thank you very much. Bye bye. See you tomorrow।